Right. So what I'm trying to do in this paper is to bring together two debates which are usually conducted separately, or always until now conducted separately. Namely, one debate about how we should understand the metaphysics of relations, whether they're neutral or have direction and so on. And the other debate about how we should understand second order logic and how we should understand quantifiers as they're used in the second order logic. What I'm going to argue, putting these two debates together, is that contrary to what is quite often said, second order logic is not the logic of relations. It's a mistake to think of second order logic as being the logic of relations. Why not? Because I'm going to claim we cannot interpret second order quantification as quantification over a domain or a range of relations. Therefore, I'm going to claim, contrary to what a lot of philosophers claim these days, second order logic isn't viable as a framework for metaphysics. Okay. First, I'm going to offer some preliminaries. So by a second order language here, I just mean second order quantifier rules are first order quantifier rules. So we have a scheme for comprehension, which we'll come back to later. That just says that for every formula, that there is a corresponding relation. So here in the comprehension axiom, we've got a formula phi, and what the comprehension principle tells us is there's a corresponding relation R, some R that corresponds to that formula. Okay, what do I mean by converse predicates? Well, I just mean roughly something along the following lines for the kinds of languages that we're typically talking about, which is that if one relation occurs in a context incurring a collection of names, then you can permute the names, and the result is another context, which is true or false depending upon whether the first one was. Of course, that's not going to apply to all languages. Francesca will tell me that it's not going to work for Latin, which doesn't use the order of the names to express the claim. But something you can have we can fill out the details for different types of language in different cases. But for now, that's what I'm going to mean by converse predicate. By converse relation, what I'll mean is a relation which is such that two relations just if one is born by A to B in that direction, then the converse goes the other way, not as a matter of accident, but not of necessity. Okay, so that's all very familiar. Here's an important distinction for the argument I'm going to give. I'm going to distinguish between lower order and higher order predicates. And I'm going to characterize a lower order predicate as what you get when you subtract a name from a singular statement. So the most straightforward case, if you subtract a name A from the sentence FA, you end up with a predicate F phi. So F phi is you subtract the zero level name from the sentence, you end up with a first level predicate. You can then use this first level predicate to generate higher order predicates. So if you subtract F phi from everything as F, what you end up with is the higher level predicate for all X phi X, the second level predicate, which is the quantifier sign. I'm going to be talking about a special class of higher order predicates which are revealed in this way when we subtract relation words from whole sentences. Okay, here's an outline of my argument. So there's going to be a dilemma. Either pairs of mutually converse predicates co-refer or they don't. And either way, I'm going to argue we have problems. So here's the first horn. Let me just outline the two horns of this dilemma. The first horn roughly corresponds to the view that relations are neutral, understanding these two different ways of speaking. Above and below, there's just one relation. Now, if we go down that route, if above and below co-refer, we lack an understanding, I claim, we lack an understanding of the relevant class of higher order predicates, which are required for second order quantification over a domain of relations, i.e. predicates which are true or false of the reference of polyadic lower order predicates, independently of how their reference are specified. So the first horn is going to claim that if predicates co-refer, then quantifying over what they refer to isn't an option, because we can't say the kinds of things we need to be able to say about what those things are. That's the first horn. The second horn is that roughly corresponds to the view that relations have got direction, so that converse predicates don't co-refer, but they pick out different biased relations. If you hold that view, then I claim that we can make sense of quantification over relations, but only at considerable metaphysical and semantic cost. If there's time, I'll argue that for some further claims that feed into this diagnosis of how relations and higher order logic interact, by arguing that relations and predicates don't literally share extensions, and that relations don't have unique extensions. Okay, right, now first horn of the dilemma. So what I'm arguing here is for the conditional at the top of the page here. If mutually converse predicates co-refer, then we cannot quantify into the positions they occupy in a sentence. So suppose these two first level predicates co-refer underneath and on top of. And I'm imagining here, I'm looking at the Alexander mosaic, and I'm seeing a picture of a representation of Alexander sitting on top of his horse Bucephalus. Here's the first interesting fact that emerges from supposing that relations are neutral and that above and underneath and on top of co-refer, is that a second order logic in this context is going to fail of extensionality. That's because if on top of and underneath co-refer, then I can go from 1, Alexander is on top of Bucephalus, to 2, Alexander is underneath Bucephalus, because on top of and underneath co-refer. But that substitution has taken us from truth, namely 1, to falsity 2. It's a failure of extensionality because supposing those expressions co-refer, those two predicates co-refer, then 1 or 2 are made up out of co-referring expressions arranged in the same way. Nonetheless, one is true and the other is false. So having neutral relations combined with the semantic claim that underneath and on top of co-refer means that second order logic cannot be extensional. It also follows from 1, Alexander is on top of Bucephalus, that it's not the case that Alexander is underneath Bucephalus. If we suppose that it's legitimate to replace co-referring expressions with the same bound variable, then quantifying into the predicate positions of 1 and 3 and conjoining the result, we get a contradiction. We get 4. The sum phi such that Alexander phi Bucephalus, and that very same relation is such that it's not the case that Alexander phi Bucephalus. So I don't think that's a deep fact, a deep problem for second order logic, for reasons that we'll come back to. But I think what's more important is it's a symptom of a deeper malady, which already arises from just considering 1 by itself, which is that we cannot even understand the simple transition from Alexander is on top of Bucephalus to Alexander, the sum phi such Alexander phi Bucephalus. Well, why not? The important underlying fact is that, I argue, is the intelligibility of quantification over a domain presupposes what I'm calling a principle of division of semantic labor. And the division of semantic labor is this. It must be possible to distinguish between a referential expression whose semantic role is to pick something out, and the rest of the sentence whose complementary role is to say such and such about what has been picked out. The rest of the sentence must fulfill this complementary role independently of the expression whose role it is to pick something out. My claim is that with this principle in hand, you can see that simple relational sentences don't admit of this division of semantic labor, and therefore you can't quantify into them. But why should you believe the division of semantic labor. I mean, you see appeals to it in, for example, Quine and Strawson when they're talking about predication, but why would you believe it? Well, I think in the contemporary environment in philosophy of language, everyone's talking about contextualism. Well, not everyone. Many people are talking about contextualism, and we're all open to the idea that the significance of an expression may be modified or interact in complex ways with other expressions in the different contexts in which they occur. So it may sound like the division of semantic labor is just too simple-minded a way of approaching language. Well, I don't think that's the case. I think that there's a simple argument for it that shows it's not just being simple-minded. So suppose the division of semantic labor is false. So I'm going to have a reductio argument here for this principle. Then the capacity of the rest of the sentence to say such and such would be nullified by the extraction of the referential expression. So suppose we're in the context, so we've got some context phi x. If you subtract the x and you're left, the idea is that destroys the phi, the bit that's left over. But then we could not use the rest of the sentence, the phi, to say such and such about the value of a variable upon an assignment of values to variables by replacing the referring expression with a bound variable. In that case, the idea behind the rule of existential introduction will be undone because we cannot intelligibly say that what is true of a certain item picked out by a given referring expression is true of something. So look at the case where the division of semantic labor works well, which is just for ordinary predicate calculus. You start off with a sentence fa. You suppose that the name A picks out an object and that A satisfies the predicate psi. You can then say that there's some object in the domain that satisfies psi, even though that object is no longer named as A. So you can say something is F. Now, what's crucial there is the F part of the sentence survives the extraction of the name, and then you can use the F to describe something in the domain independently of whether it's named by A, the name A. What I'm going to argue is that we can't do the same kind of operation when it comes to second order generalization. So try it for ARB, and we want to go from ARB on the left-hand side of the page and end up at some phi, A phi B, where we're quantified into the predicate position on the right-hand side. What that requires is that we pick out the predicate and say that, so we extract, we identify the predicate, and we say it picks out a relation. And then what it's going to, whatever that thing is, what the sentence is saying is that it's satisfying the higher order predicate, A phi B, where A phi B is the higher level predicate, which is left over once you've extracted the lower level predicate. What does it call it? R. Now, what I'm going to claim is that we don't understand A phi B the way that we understand F psi. A phi B does not have a significance that survives the extraction of R the way that F survives the extraction of A. That's the basic argument. Okay. Why do I think that? Well, let's go to Alexander is on top of Bucephalus again. It doesn't exhibit my division of semantic labor, because what's left over once you subtract on top of lacks self-standing significance. Why? Because when the variable phi is replaced by, is on top of, the result is a sentence that says that Alexander is on top of Bucephalus, whereas when it's replaced underneath, the result is a sentence that says Bucephalus is on top of Alexander. So the significance of having A on the left of the sentence and B on the right of the sentence shifts according to which predicate I slot in between the A and the B. By contrast, the significance of the name F, when I quantify into a FA, the significance of the word F is constant, regardless of whether I substitute B or C or D. When we get to the predicate case, that's not, when we're thinking of these higher order cases, that's not happening. the significance of the flanking expressions differs according to which expression is inserted in the slot, into the higher order slot. And so we can hear that vividly in this case. So from far being saying what one says about the referent on top of is incompatible with what two says about the referent of is underneath. So since one fails to exhibit my division of semantic labor, I claim that quantification into predicate position is unintelligible. Okay. Just to reemphasize this, the general point is that you need to have, in order for quantification, objectual quantification over a domain to make sense, we need to intelligibly be able to say what it is that we're quantifying over, or express something true or false of what we're quantifying over. When we say that there's something that's F, what we're saying about the objects in the domain is that at least one of them is F. When we try to do this with a higher level predicate, we have to say that at least one relation is such that A phi B, which is the higher level predicate, which we get when we've extracted the relation signs, that the A phi B is true or false of a thing in the domain. But my claim is that A phi B makes no sense in isolation, and therefore you're not succeeding in saying something true or false of something in the domain. So that's the first horn of the dilemma, which is that if predicates co-refer, then A phi B doesn't make sense, and therefore we can't quantify into those positions. Okay, here's the second horn. Now, if you're someone who believes that relations have got direction and that converse predicates don't co-refer but pick out different predicates, then you might say at this point, hooray for the standard view. The standard view is compatible with higher order quantification, whereas neutral relations aren't. So here's a new argument for why we should believe in biased relations or relations with direction. Well, I'm not convinced, and the reasons that I'm not convinced will be familiar from some of the objections to the biased view. So here's my argument for what goes wrong if you hold the view that relations have got directions and that mutually converse predicates don't co-refer. If they don't co-refer, then I claim we cannot quantify into them without onerous semantic and metaphysical costs. Why is that? Well, even if converse relations are admitted, higher order predicates of the form A phi B are still required for the intelligibility of quantification into the position of converse predicates. I mean, the division of semantic labor was a general principle. It didn't depend on holding a particular view about predicates or a particular view about relations. So the question still remains, do we understand A phi B if there are converse relations? And I'll argue that we don't, or at least we can't understand it without saying some things which are extremely strong, stronger than I think at least some people who believe in relations having direction would feel uncomfortable with. Well, what we need to understand A phi B is we need a way of understanding it so we understand it quite independently of whatever predicate sign can fit into the argument position, into the phi slot. In the written version of this paper, I provide arguments for why we're forced down a certain route to how to understand this higher order predicate. But here, let me just say, here's the obvious thing to say. What A phi B means is A comes first and B comes second in the relation which is designated by whatever relation sign fits into the argument position. So higher order predicates of the form A phi B stand for the property that a relation has if it applies to A first, B second, regardless of how that relation is picked out by a first level predicate. So Alexander phi Bucephalus is satisfied by a relation just in case R applies to Alexander first and Bucephalus second, whereas Bucephalus phi Alexander is satisfied by a relation R, just in case R applies to Bucephalus first and Alexander second. That's the view. That would work. That would satisfy the division of semantic labor. That would give us second order quantification. But the view has costs, some of which I've partly spelled out before. So here are some semantic costs of the proposal. If that view were right, then you would not have understood singular constructions in which you say one thing is related to another, unless you understood that some things were coming first and some things were coming second in the relations which were being whose distribution was being described. But we don't find ourselves explaining to a child or a foreign language speaker that in order to understand what Alexander is on top of Bucephalus means, she or he must appreciate that Alexander comes first, Bucephalus second with respect to the relation in question. So it doesn't seem to be a feature of our translation practices or our teaching practices or a feature of language acquisition that we learn how to use these ordinal notions when explaining or teaching what it means for one person to kiss another or love another or be taller than another. The notions of first and second just don't come into play. Similarly, I don't think it's plausible that we implicitly rely upon there being a fact of the matter about which thing comes first, which second, when we describe one thing being top of another. So we fail to mention that Alexander comes first, Bucephalus second in the relation that is on top of stands for when we describe the scene depicted by the Alexander mosaic. We don't think our description is thereby incomplete. But if this view were correct, it would be incomplete. That would be something that was missing. But so far from it seeming missing, it seems arbitrary. It seems you might as well say that Bucephalus, you can swap them around. One could be first, one could be second. These ordinal claims seem a matter of indifference to what's on top of another. Okay, now let me expand upon the metaphysical costs. The Alexander mosaic, as well as depicting that Alexander is on top of his horse Bucephalus, he's also to the left of Darius. We don't presuppose that in the scene depicted that Bucephalus and Darius have something in common because both come second relative to Alexander in the respective relations for which on top of and to the left of stand. Okay, so what I'm saying here is we don't draw comparisons about between how these two different relations relate, which is expressed in terms of these ordinal notions. We can generalize the problem, nor do we presuppose that Bucephalus has something in common with every other thing in the universe that comes second in an arbitrary non-symmetric relation. If this proposal were correct, if we really do make sense in general in a manner which is indifferent to the way that we express relations, then A phi B means A comes first and B second, and we can apply this quite generally across all relations to their application throughout the universe. So if that proposal were correct, there'd be a fact of the matter about Bucephalus having something in common with every other thing that comes second in any other non-symmetric relation. But there's nothing in our descriptions which commits us to the relations which is on top of and to the left of, respectively, applying in some absolute sense to Alexander and Bucephalus on the one hand, and Alexander and Darius on the other. And the problem only gets worse if we compare the application of, so here I'm asking you to compare in a non-arbitrary way the ordinal application of two binary relations. But the problem is worse if you have to compare the application of a binary relation with a ternary relation or for any other arbitrary n-ary relation. Why should we coordinate? How can we in a non-arbitrary way coordinate how one applies to something first and second with what something else applies second and third, and so on? So my claim is that if you understand A phi B in this strong way, you have a principle of absolute ordering for the universe. There's nothing in our practices. So it's like having an axiom of choice, except it's much, much stronger. Because it's not just you can choose one thing that applies to first, it's that you can choose for any n things, the 1th, the 2nd, to the nth that it applies. But we have no way of recovering this principle of absolute ordering from our practices. It's not like the axiom of choice, which you can say informs mathematical practice. The principle of absolute ordering doesn't, and we have no idea of how to discover one. Now, just to be clear, I don't think that, so I said that if you believed in the principle of, I said that you might think that from the first Horner dilemma, that this would give us a new argument for believing in biased relations, because we avoid the problems of violating the division of semantic labor. I don't think that everyone who goes down this route, so suppose you did believe in biased relations, it's not obvious to me that you have to think that A phi B expresses this higher order predicate of coming first and coming second. It might be that you believe in biased relations, but think of them in a more modest way. Namely, that you think that they have direction, but you don't think you can compare in some absolute sense the direction of one relation with the direction of another. But if you did hold that route, then you would have the same problems as the person who believed in neutral relations, because it would still be the case that because if you think there's no absolute direction, then you cannot appeal, then you can't appeal to coming first and coming second to give an absolute significance to A phi B. Okay, how am I doing for time? Right. To fill out this picture, I'd like to reflect a bit on the comprehension principle, which is at work here. So let me just go back. So there's the comprehension principle. It says that for every predicate, there's a corresponding relation. All right, where did we get to? Now, the comprehension principle is often characterized as showing that second order logic is an abundant source of relations. I imagine that Francesco is happy to embrace this view of relations as comporting with this higher tier of abundant relations, because every formula determines a relation regardless of whether it's natural or sparse. Now, this view of things has been endorsed by Williamson in his Modal Logic as Metaphysics book, where he argues against the restriction of comprehension to natural properties and relations. He does so on the grounds that the extensive literature on naturalness has failed to supply a fruitful logic of natural properties and relations. And by contrast, he claims comprehension is an informative logical principles which depends on the absence of any natural restriction. It depends on the absence of any naturalist restriction, just in the sense that it just says that for every formula, natural or not, there is a corresponding relation. Now, the relevance of this to our previous discussion is the antecedent of the first horn of our dilemma is equivalent to the relatively sparse doctrine that mutually converse predicates co-refer. So this makes it sound as though if you're a neutral theorist, then what you have, then you've gone down the natural route, and that's already to violate the superabundant view of comprehension. So already conflicting with second order logic as it's ordinarily understood. So isn't the neutral route already incompatible with comprehension, i.e. second order logic? And I want to say no. So there's no quick argument to be had here. The neutral view doesn't violate comprehension, is what I want to say. Why is that? Well, comprehension does not require that each formula determines a unique relation, but only that no formula is empty. It just says for every relation, every formula phi, there's a corresponding relation. But saying that no formula is empty, that every formula is full, so to speak, that's consistent with different formulas having the same referent. And that's because each instance of comprehension is bound only by an existential higher order quantifier at the front, the sum R that corresponds to phi, but there's no uniqueness through it in there. So the neutral view isn't incompatible with comprehension as Shapiro understands it, nor is it incompatible with comprehension as Williamson understands it, if you're a neutral theorist, because you don't need to throw in naturalness to say that converse predicates co-refer. You're not appealing to the notion of a natural property to make that claim. However, I think there's another argument that people sometimes have in mind, or lurks in the background, and I'm going to call it the bad argument. There's a bad argument in the background which suggests to people that comprehension does give you biased properties, biased relations. And I'm going to click, and that this shows us that if we believe in comprehension, then we should reject neutral relations. Let me try and explain the bad argument. So first, let's look how Shapiro interprets comprehension. He puts it in the following terms. This scheme asserts in effect that every formula determines a relation, or more precisely, that for every formula, there is a relation with the same extension. That's the key claim, I think. For every formula, there is a relation with the same extension. Using that line, I think you can generate what I think is a bad argument for saying that comprehension is incompatible with the neutral theory, as I've understood it. Okay, so here's the bad argument. So, yeah, okay. Supposing that before and after have got different reference. Sorry, so I've got the same referent, and we're going to show that that's not going to work. Now, let's look at the predicates before and after. Even if you allow the neutral theorist to claim that they co-refer to the same relation, they're going to have different extensions. They'll have different extensions because they're satisfied by different pairs of events. Roughly speaking, two different sets of pairs where the events are swapped over. Suppose that these predicates stand for the same relation, even though they have distinct extensions. By comprehension, taking as meaning for every predicate there's a relation with this same extension, when we quantify into the position of an occurrence of before, we affirm there is a relation R, call it R, that shares the extension of before. That's how Shapiro is understanding comprehension. For that predicate, there is a relation that shares the extension of the predicate. Similarly, when we quantify into the position of an occurrence of after, we affirm there's a relation called R star that shares the extension of after. But before and after have distinct extensions, and since relations share their extensions with the predicates that express them, R and R star must be distinct too. So here we have an argument from roughly speaking, from comprehension to something that looks like the conclusion that there must be converse relations. Well, I want to say this argument doesn't work. That's why I'm calling it the bad argument. It has two suppressed premises. First, that relations and predicates literally share extensions. And second, that each relation has only one extension. And I want to say both of those claims are false. What are we doing for time? Okay. Here's why one is false, the claim that relations and predicates literally share extensions. Well, the reason for it is that extensions are made, they're not found. And they're made by providing a rule of interpretation for coordinating a set theoretic tuple with a relation. And roughly speaking, it's something like this. The extension of an n-place predicate is a set of n tuples such that each tuple includes an assignment of values to the variables of the predicate, and relative to that assignment, the predicate is satisfied by the coordinates of the tuple. But then, since relations don't have variables, you can't have this kind of rule for coordinating a relation with a predicate, an extension with a predicate. You can't coordinate an extension with a relation the way that you do with a predicate, because relations don't have variables. Okay, assumption 2 was that each relation has only one extension. Well, why do I think that's false? Well, despite the fact that you can't coordinate an extension with a relation the same way that you do with a predicate, you can use a set theoretical model to encode information about the instantiation of a relation, but again, only relative to a rule of interpretation. So take the set of pairs, for example, such that the first element of each pair is on top of the second. We can take this set to be the extension of the relation, which is the on top of predicate stands for, because relative to this rule, this set of pairs represents how the relation is instantiated. Call this extension T. By parity of reasoning, we can also take the set of ordered pairs such that the first element of each pair is underneath the second to be the extension of the relation, which the underneath predicate stands for. And relative to that converse rule of interpretation, the first element of each pair is underneath the second. Call this extension U. But since we're supposing that on top of and underneath co-refer, U and T are both perfectly good extensions of the same relation. Neither T nor U have a claim to be the extension of the relation for which both on top of and underneath stand. So T and U, relative to their rules of interpretation, embody the same information about the instantiation of the relation for which both on top of and underneath stand. So it must be a mistake to think that if you're a believer in neutral relations, that a relation has only one extension. So you can't use this argument to go from comprehension to biased relations. Let me quickly go to the conclusion. Williamson, in his Modal Logic as Metaphysics book, he considers various objections where people say they don't really understand his higher order quantifiers. Williamson argues that there's no avoiding using higher order quantifiers to explain themselves. That's the only way to explain them. And that's because he argues introducing second order quantifiers brings about a sea change in the expressive capacities of a language. So we cannot expect to explain second order quantifiers before introducing them. Nevertheless, he argues we can account for second order quantifiers retrospectively by seeking, and here I'm quoting, explaining how our understanding of these quantifiers is rooted in our understanding of closed expressions of the same category as the quantified variables. Well, maybe there's something to be said for that in general. But in this particular case, I think there's no help here. And that's because the division of semantic labor tells, so long as the division of semantic labor remains a good principle, there's no way of understanding the higher order quantifier unless you can isolate and comprehend a range of higher level predicates, which are true or false of the higher order domain, independently of the predicates which are used to express the relations in that domain. But the problems we've seen with the division of applying the division of semantic labor to predicates, to relational predicates, shows that we just don't get that understanding of those higher level predicates. So we're not finding those, the understanding of those higher level predicates is not rooted in our understanding of the semantic values of the lower order expressions. That's what I've argued. So I think that this root out really doesn't help him. So, sorry, I rushed that last bit a bit, but let me just finish off with a strategic sense of where we are. This is where I had second doubts last night and began to worry about how we should conceive of the result of this. It seems to me there are three. There are a variety of different ways of responding to this situation. One is to leave second order logic as it is, but instead of conceiving it as quantification over relations, conceive it as quantification over extensions. So over sets. So you might think of this as an argument for saying that you shouldn't conceive of it as quantification over a domain of relations for the problems we've identified, but that doesn't show that you can't conceive it as quantification over sets, as indeed that's the way that Shapiro in his book says we should think of as the standard semantics, that really it's just quantifying over extensions. Williamson argues that that's not good enough because we want to talk more generally than set theory. But you might think of this argument here might show that it was wishful thinking to think that you can talk more generally than extensions. That's one way out. Another way out would be to abandon the objectual interpretation of quantification altogether and simply say we shouldn't think of it as involving talk of a domain at all. And indeed, this is the way that Prior suggested in objects of thoughts that we ought to go. But of course, if you go this route, then you're no longer using that. So if you go down this route, then there isn't any associated domain. It's simply a way of speaking generally without any ontological commitment. The third possibility is you just simply give up on second order logic altogether. Now, this would be the Quinean route out. So you might think of this as a vindication of Quine's skepticism about second order logic, albeit for different reasons than the one that originally gave. His reasons were basically that you confused names and predicates. To think you could quantify into predicate position was to confuse a predicate with a name. And various people have responded that just begs the question, or you don't need to think there's that kind of mistake in second order quantification. Boulos, for example, pointed this out. But in a way, you might think of the story I've told here as a vindication of Quine's complaint. It's because predicates, lower and higher order predicates, don't have their significance independently of one another, that you can't extract predicates and quantify into their positions in the way in which you can when you quantify into name position. So you might think this vindicates the Quinean outlook. It's not that you're confusing names with predicates when you quantify into second order position. It's that rather that you have to think that predicates can be isolated from the frames in which they occur in the way that names do. And I've argued that actually you can't isolate predicates and understand their significance independently of the context in which they occur, the way that names can be isolated. I'll stop there. Thank you.